Hi, welcome to a tutorial video on the new loading and timing features in the Straos platform. I'm just going to quickly take you through an example of how to use these new features on an existing shot design that I have in the system. So as you can see, I've done my drilling design prior to this and created a pattern with 3 rows of 15 holes in each row. Now, the first thing that I'll show you in this new set of modules is the dip data module. So before designing the loading, it's important to know the actual depth of your holes as opposed to just the design depth. And this is so that you can make sure that you're getting the right charge masses calculated for each hole, and that you have the correct deck lengths in your loading design. So the way this works is quite simply, when you open this module up, it's just a pop-up. It'll show you for each hole what the design length is and allow you to type in an actual length. And the way that this can practically work in your field operations is you can either print out dip sheets, which you can take into the field and dip the holes with, and then record the actuals, come back to the office and type them in. This is an example of what the sheet looks like. Or the other alternative is that you can export the dip data as a CSV, which you can then open in something like Excel or any other kind of spreadsheet tool on a mobile device like a phone. So that's a way that you can export all the hole lengths, design lengths, and then a blank field for actual length, or the filled in field for actual length if there are numbers in there. Basically, this whole table exported as a CSV and manipulate it in the field on a mobile device. You can then come back, hit import CSV, drag and drop it there, and it will come back in and update all of these fields. So that's a quick overview of how to update the hole lengths to set you up for loading. Once you've done that, you can then come into the loading design tab. And here I've already set up my site product list, but if this is the first time that you're using this module for a particular site, it'll ask you to set up your site product list. So don't worry if it's doing that for you. I'll come back and address that later. If you have set it up before, then this is the first screen you'll see if you haven't got any loading information in there yet. And this is basically an optional shortcut way to load all the holes quickly if you're doing something simple like just loading all the holes to stem height, or loading holes using a pre-existing rule set that you've created in the past. So first I'll show you what it would look like to load all the holes to a particular stem height. This is basically just giving you a field to enter what the stem height is that you want, what the explosive is that you want, what booster you want to use, what detonator you want to use for each hole. And then if you want to single prime every hole, double prime every hole, or double prime if your hole is longer than a certain length. So those are your options. It's basically for getting you started with real simple, quick method of loading every hole in the shot, which will then allow you to come back and tailor each one individually afterwards as well. So it's not locking you into that simple loading design. It's just giving you a quick starting point. The next quick way to get started is if you have loading rules already set up, you can choose this second option, load all holes from loading rules. And basically this is one step more complicated than just straight loading them all to a stem height. If you've set up load rules in the past that, for example, might load all the angled holes with packaged product, but all of the straight holes with bulk product, for example, you might have that set up here as a loading rule set, in which case you can just choose that loading rule set. I have a few of them in here. And then you can, once you've chosen the rule set that you want, you can just hit apply and it will load all of your holes based on the conditions in the loading rule sets. So for this one here that you can see, I've set it up so that you can preview basically what happens in each load rule set. So firstly, it'll look to see if any holes are less than 1 meter, and it will load them like this. Then it goes to rule B, and it will check if there's any that have inclination less than 1 degree and length greater than 0 and length less than or equal to 50, and then it'll load them like this. So if I hit apply, it'll basically go through those two conditions and apply that loading to those holes based on that. Cool. So those are the two kind of shortcut options for just getting loaded really quickly. The last option is that you can skip straight to the shot, which will just bypass the shortcut methods and just take you to the shot where everything will be blank. In this case, I'm gonna just do this first shortcut method of load all holes to stem height using these settings that I set earlier. I'll hit apply. And as you can see, all rules have been applied successfully. All my holes have been loaded, single primed with ANFO, just like I said in my design there. So from here, I can see that all the holes have been loaded because they have this dotted line around them. I can then double click on a hole and that'll bring up the individual loading for that hole. So here I can see, as I asked for, 2 meters of stemming, and then the rest of my whole column is ANFO. I can see from here the amount of ANFO in the hole is about 99 kilos. I can see that here as well. I can see basically the sub drill here, so it shows me where the floor is and it shows me what the hole length is. And I can, if I then want to come and edit something, I can move over to this table on the left here, and I can edit this hole in a few different ways. So the first thing that I'll show you is you can edit the density of the product. So if I'm saying actually here ANFO is 0.86, I can update that. It'll update the charge weight, update over here. And then you'll notice down here, as soon as I make a change, before I move on, I have to either save the changes or undo all the changes. So I can keep editing in here as much as I want, but at the end of the day, if I've made a mistake, I can just undo everything and it'll bring me back to where I was before. So you can have a play around here without worrying about losing where you're at. So I can change the density. The other thing I can do is change the lengths of the columns. So if I want more stemming, I can just click the up arrow here. It adds another meter of stemming. Or I can change this number by typing into the field. It changes things as well. That's my length. I can do the same on the ANFO column. I can also change the priming of the hole. So at the moment I have it single primed. Here I have my non-electric 500 millisecond in-hole det selected. If I want to change the detonator, I can do that here to either another non-electric one or an electronic one. I can change the booster that I'm using here as well. And so these two drop downs on top of each other represent a single primer. So one detonator, one booster. equals 1 primer. If I wanted to double prime the hole, I can add another one to the top. And what this does is then allow me to choose detonator and a booster again for that second primer. And now you can see the hole is double primed. So the thing about priming that I'll note is you don't have to choose the lead length. It will automatically assign the first primer to the bottom of the hole and automatically tell you what lead length you need. So in this case, our hole is about 15.5 meters, and it's automatically picking that we need an 18 meter lead length for this one. And it works this out based on obviously the length or the depth of the primer. So this one's going to be shorter because it's at the top of the hole. And then it accounts for needing an extra 2 meters or 6 feet of lead hanging out the top of the hole. And it will then round that up to the nearest available lead length option for the product that you've selected. So that's how priming works. Next, I'll show you how to add a new deck. So say we actually want to put something heavier in the toe. I'll just pick another random product and add a few meters of that down the bottom. So you can see I've just added 3 meters of this S300 product to the bottom of the hole. It's automatically assigned at the density based on the average density of that product. But again, I can change it. And you can see if you hover over the density entry field, we have the recommended limits for density for that product based off its tech data sheet. And that's being used, multiplied by the 3 meters of product to calculate the charge weight of 27 kilos in this case. I can then add a primer, and it'll just by default pull through the settings of the last primer that I used. Cool. So that's adding a new product, a new deck. If I want to, I can add another one. Say I wanted to put a stemming deck between them. I can put that down here, pick it up from the side, drag it up here, add a meter, and you can see over here now that stem deck's in the middle of these two decks. So you can drag these around. You can remove them with these crosses here, and you can then fix your hole up so it goes back to the top. And that's basically your whole editing, your whole loading editing for a single hole, all done there in one place. Cool. So I will undo those changes now that I've shown you all this. But you could save them, and then if you want to move on to the next hole, you just click these arrows to move between holes. So that was editing an individual holes loading design. If you want to edit multiple holes loading designs at once, that's where you use loading rules. So I started mentioning this a little bit before, but the way that loading rules work is that it's a series of conditions basically, and then a series of loading templates over here on the right. So I'll set up a new load rule set to show you. Test rules set. Cool. So we're in now test rules now, and you can see it starts off blank. And what I need to do just to get started is to add a new rule. And the first thing you do with a rule is you add a condition. So I'm going to say for each of my holes where the inclination is greater than 0, I want to load it with, and then because this is highlighted, this is what I'm loading it with on the right here. I'm going to say 2 meters of stemming, and Then I'm going to load it with this package product at the back here. Now I'm adding links to these. These are really, these are used to build this diagram. In reality, these links only matter if you do not have the, they only matter for decks where you don't have this var box ticked. So what's going to happen is this template is going to be applied to a hole that might have any length. So here we've got obviously a 7 meter hole in this template, but the template could be applied to a 9 meter hole. And so the way that we tell the system to work out how to fill that 9 meter hole with this template is we have one of the decks being a variable deck. And so in this case, I'm going to say it's the package product here. That's the variable deck by ticking this checkbox. And what that means is that if I apply this template to a 9 meter hole now, it will it'll put 2 meters of stemming at the top, and then this variable deck down here will expand or contract to fill the rest of the space. So that'll be instead of 5 meters, this will be 7 meters of product in that bottom section. I'll then add primers to that to make sure that that's all good, and then that's going to be my my first loading rule. Now my second rule in the set is going to be else, and this is a good one to end on because basically it means that all your holes will be loaded. So this one's saying inclination over 0, do this, use package product. And this one's saying for everything else, do whatever is in this template over here. So I'm again going to say 2 meters of stemming. I'm going to make the Anfo deck my variable deck again. I mean, this because it's variable can be any number. It doesn't really matter. I'm going to add the primer again over here. And so the effect of this this load rule set is going to be, it's going to look at each hole and it's going to say, is this hole have inclination greater than 0 degrees? If the answer is yes, it'll do this. If it's no, it'll go to the next rule. The next rule, it's going to say, okay, else, well, that means the hole is definitely going to fall into this category. So then it's just going to apply this rule to that hole. So every angled hole basically will get loaded like this. Every other hole will get loaded like this. So this is a pretty simple way to set up loading rules and conditions. You can make it more complex if you want. You can add a lot, as many rules as you want. You can have multiple conditions in the same rule if you like. But for this case, I'm going to keep it simple. Angled holes get packaged, straight holes get bulk. I'm going to save this rule set and close it. And now I know that all my holes are vertical, so to demonstrate how these rules work, I'm going to come back into here and I'm going to make into my drilling design, and I'm going to make one of these holes angled. Cool, so you can see our first hole is now at a 5-degree angle. I'll come back to our loading design module, and the first thing I'll do, because these holes already have loading data in them, is select all the holes. I'm doing this by holding down Control or Command and dragging, and I can drag a box to select multiple holes. Once I've selected multiple holes, I'm going to click Clear Loading from selected holes, and that has removed the loading, as you can see. If I double click on them, they're empty. And so now that all my holes are empty, I'm going to go find my test rule set that we just created, and I could, if I wanted to, just apply this to some of the holes by selecting them and then hitting apply to selected holes. Or in this case, what I'm going to do is just click apply to all holes. It's going to say, do you want to apply to all holes? I say yes. And here it gives us a confirmation that it's worked. You can see that our hole number 1 got rule A, which was the rule that said if it has inclination greater than 0, do this, load it with packaged. And the rest of them got rule B, which was if anything else. So if it doesn't have any inclination, then do rule B. So that's matched with what we expected it to do. We can see if we go into this one, we've got packaged product. And we can see if we go into this one, we've got ANFO. So that's basically a quick overview of how loading rules work. Next, I'll show you the reports that get generated. So down here, you've got 3 different reports. So once we've designed the loading, we've basically, for each hole, got a list of decks, of stem lengths, decks. We need to communicate that to people in the field so that when we're out there loading the shot, we can have an idea of how much charge is supposed to go in each hole, and we have somewhere to write down how much did go in each hole. We also need to know how much stemming we're holding on each hole, sorry. Or if we have multiple decks, the height that each deck comes up to. So that's the kind of information that we communicate using the loading sheets, which I'll open now. And here we go. As you can see, it basically prints off a table. For each row, it has a table, and it will show you for each hole in that row what the length is, what the rule that's been applied to that hole is, so that you can reference that. If you just have stemming in the top deck, it'll call that, it'll just say it's a stem deck, and it will just tell you the stemming length here. It'll then tell you how many primers are going into that hole. It'll show you the product name that's going into that hole. So we've got our packaged product here, and we've got our ANFO for the rest of them. And then it will tell you design mass of that product. So for these ANFO holes, for example, if you're coming along with a truck, with an auger, for example, the truck operator can have this sheet and see, okay, 88 kilos is what's supposed to go into the hole. If it gets up to 110 or something, it's probably a good time to cut off and see if there's anything going wrong, like a cavity, for example. Then at the end of the day, or after loading each hole, recording the actual mass can be done by hand in this column.